This is Geometry, Section 6.6, Part 1, Trapezoids. So, trapezoid is another kind of quadrilateral. It is a quadrilateral with one, and exactly one, so only one, pair of parallel sides. Okay, so the parallel sides in a trapezoid looks like this. We've got three examples down here. So one of the pairs of sides is parallel. So the parallel sides are called the bases, and the non-parallel sides are called the legs. Two angles that are connected to the same leg. So here in this trapezoid, these are the bases because these are the two sides that are parallel. The legs would be TR and RA. So two angles that are connected to the same leg, for example, this leg right here is connected to this angle and this angle. So the two angles that are connected to the same leg are called leg angle pairs. And then the two angles that are connected to the same base would be called base angle pairs. Well, we'll get to those in a second. So leg angle pairs, this angle and this angle, are going to be supplementary since these lines are parallel. These are same side interior angles going back to first semester. And that means that these two angles are supplementary. So naming for all three of these trapezoids, naming the legs, the bases, the leg angle pairs, and the base angle pairs. So this one, like we said, the legs are T, P, and RA. The bases would be TR and PA, the two that are parallel to each other. Here, the two that are parallel are WD and IN, so those are the bases, which would make the legs WI and DN. Here, the legs, the non-parallel ones, BO and SG. Here, the parallel ones, or the bases, are BS and GO. Leg angle pairs, here we talked about, so this leg right here has angle P and angle T touching it, so T and P, and then R and A would be the other pair. That would mean that the base angle pairs, so the ones touching the same base, would be T and R, and then P and A. Over here, leg angle pairs, so one's touching the same leg, so the leg right here is WI, so it's going to be, angle W, angle I, and then the other pair is going to be angle D and angle N. Base angle pairs, so touching the same base, here this base is WD, so those angles, W and D, and then I and N. Here, I'm just going to write the letters instead of using the angle mark also, so the leg pairs, this leg is BO, so angle B and angle O, S and G, and then angle B, angle S, angle G, and angle O for the base angle pairs. Find all the interior angles of the trapezoid. So we have to find our leg angle pairs because we know that those are supplementary. So here are the parallel sides, which means this piece is a leg. So that means the leg angle pairs, so angles touching this leg, are supplementary. So if this one is 80, this one has to add up to 180 with this. So this one would have to be 100. So 180 adds up to 180. This is the other leg. So this angle, which is 90 degrees, has to add up to 180 with this angle. So 90 plus 90 is going to give me 180. Over here, parallel sides are here and here. So this angle and this angle have to add up to 180. So I take 180 and subtract 85, and I would get 95. And then this angle and this angle also have to add up to 180. So if this one's 50, I would get 130. So touching two angles that are touching the same leg, or one of the sides that's not parallel to the side across from it, have to add up to 180. 85 and 95 add up to 180, 50 and 130 add up to 180. Over here it's a little bit trickier. It looks kind of just like a rectangle, but these are our parallel sides, which means my leg angle pairs are going to be touching this side and this side. So if this is 93, this one has to add up to 180 along with that one. So 180 minus 93 gives me 87. And similarly down here, these two have to add up to 180. So 180 minus 88 leaves me with 92 for that angle right there. Down here, proving that this shape is a trapezoid, First, we're going to have to find the slopes of all of these sides and then compare them to see which sides are parallel, which sides are not. So let's start with AR. AR, if I count the slope, I'm counting up 1, 2, and over 1, 2, 3, 4, 5. So my rise over run is going to be 2 over 5. AS, from A to S, I'm counting, or from S to A rather, I'm counting up 1, 2, 3, 4, and over 1. So my slope is going to be 4 over 1, or 4. From R to M, I'm counting down 1, 2, and over 1, 2, 3, 4. So since I counted down, that's negative 2 over 4, which reduces to negative 1/2. And then for MS, I'm counting up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 10. Oops, I'm sorry. Erase that. 4 over 10 for our rise over run. So 4 over 10, which reduces to 2 over 5. So in order for two lines to be parallel, they have to have the exact same slope. So we want one of these pairs of sides to be parallel. It looks like AR and SM are probably parallel. And if we look at the slope, 2 over 5 is the same as 2 over 5. So AR is parallel to MS, and these two sides need to not be parallel in order for this to be a trapezoid, because if both pairs of sides are parallel, then it's a parallelogram, not a trapezoid. So we need to have one pair parallel and the other pair not parallel. So it doesn't look like they're parallel, and if we look at their slopes, they are not even close to the same thing. So AS is not parallel to RM. Alright, so ARMS is a trapezoid because it has one pair of parallel sides. Okay, an isosceles trapezoid. We've talked about isosceles triangles before. An isosceles triangle is a triangle where two of the sides are congruent. So an isosceles trapezoid is the same thing. It's a trapezoid that has congruent legs. Okay, so just like for a triangle, we call the two sides that are congruent, we call those the legs. For a trapezoid, an isosceles trapezoid means that these sides are parallel and these legs are congruent to each other. So if you have an isosceles trapezoid, two things are true besides the fact that the legs are congruent. You also have congruent diagonals. So if I draw this line across, that's going to be the same length as this line across. You also know that your base angle pairs, which I said we would come back to, so your base angle pairs are also going to be congruent. So this angle right here is going to be the same as this angle right here. This angle up here is going to be the same as this angle over here, because this angle and this angle are on this base, and this angle and this angle are on this base. Alright, so each of the following is an isosceles trapezoid. Find the value of the missing variables. So here we've got these two legs are congruent. So we know from what we just said that the two angles that are touching the same base, so for example these two angles right here, are congruent to each other. So if this is 60, x is also 60. Y up at the top, we don't know what either of these two angles up at the top are. We do know that they're the same, but we do know that our leg angle pairs, so the angles that are touching the same leg, so 60 and y, have to add up to 180. They're supplementary. So to figure out y, I would take 180 minus 60, and I'm left with 120 for y. Over here, these are congruent, which means my base angle pairs are also congruent. So 110 touches this base, because these are the parallel sides. So 110 touches this base, B also touches this base, so B is 110. And then we have to find C and A. We know C and A have to be the same thing because they both touch the same base. To find them, I know that these two angles, which both touch this leg, have to add up to 180. So I take 180 minus 110, and that equals 70. So A and C are both 70. Alright, letter C over here. We've got AM, this entire diagonal is 12, which means RS also has to be 12. So RS is 12, AM is 12. RM, so this piece over here is 4x minus 8, and AS is 8. We're also told that RS, which we just wrote over here, is 12. Since AM is 12, RS is 2y minus 4. Well, since we know that it's 12, we can set it equal to 2y minus 4. To solve that, we add 4 to both sides. 12 plus 4 is 16, equals 2y. Divide by 2, so y would equal 8. Then, to solve for x, since this is an isosceles trapezoid, we know these two pieces are equal, so 8 would have to equal 4x minus 8. Write this up here. 4x minus 8 equals 8. I would add 8 to both sides, and then I have 4x equals 16. I divide by 4, and I get that x equals 4. Alright, a midsegment in a trapezoid. We've talked about midsegments in triangles as well, so it's a similar thing. So a midsegment is a segment that connects the midpoints of the legs, just like it does in a triangle. So in a triangle, a midsegment connects the midpoints of any two sides of the triangle. In a trapezoid, it connects the midpoints of the two legs, so the sides that are not parallel to each other. So if I draw in the midpoints of these two legs and connect that with a segment, that's called the midsegment. Okay, so this is the midsegment. This is one of the bases, so we'll just call that B1, and this is the other base, we'll call that B2. So a midsegment, just like in a triangle, a midsegment is going to be parallel to both bases. Since both bases are parallel to each other, just like in a triangle, this midsegment is parallel to this base. In a trapezoid, this midsegment is parallel to both bases, since those two bases are already parallel to each other. The midsegment is also going to be, so the length of the midsegment is the average of the two bases. So to find the midsegment, to average two things, we add them together and divide by 2. So if I wanted to find the midsegment, I would add the length of this base to the length of this base and then divide that number by 2. And we'll see an example of that right here. So in letter A, we have the two bases are 4 and 8. So to find the length of the midsegment, the dotted line is the midsegment. To find the length of that, we add 4 and 8, and then we divide that by 2. 4 plus 8 is 12. Divided by 2 is 6 for the midsegment. If instead you're given the midsegment and you have to find the other base, it's a little bit trickier. So if I write this in, this is 6, I can notice that to get from 4 to 6, I add 2. To get from 6 to 8, I also add 2. So to find a missing base, we can use a similar process. I can ask myself, alright, well, how do I get from 10 to 12? Well, again, I add 2. So to get to this other base from 12, I would just add 2 again, and I would get 14 for this base. So you figure out the difference between the base that you have and the midsegment, and then you do the same thing to the midsegment to find the other base. Over here is another example like the first one. We're finding the midsegment, so we just average the two bases. We add them together and divide by 2. 3 plus 11 is 14. When we divide that by 2, we get 7. Over here, similar to the second one, now we have to figure out, okay, how do I get from 14 to 9? Well, to get from 14 to 9, it's getting smaller, so this time we're going to subtract something. So we subtract 5 to get from 14 to 9, so now I'm going to take 9, and to get D, I'm going to subtract 5 again. So that would be 4. I can check my answer by seeing if the average of the two bases equals 9. So 4 plus 14. If I add that together and divide by 2, I get 18 divided by 2, which does equal 9. So this base is 4.